Okay, so we are going to, in the last lesson we looked at derivatives of the natural exponential function, you know, where we had e to the x and we looked at integrating it. Now we're going to look at what about bases other than e. So I gave you a few notes. Make sure you printed them, out and have them in front of you, and we'll go through those examples that I left blank. So you want to make sure that you, oh, sorry. Okay, there we go. You want to make sure that you have this theorem handy when we get ready to do these. All right, so when we look at the derivative of the first one, it says find the derivative of y equals 6, y equals 6 raised to 3x minus 4. All right, so we're going to look at, for that first one, this formula. We've got an a to the x type thing, so we need to figure out, or I guess it should be, actually, it's 2, not the first one, because we don't have a plain old x. We got something different. All right, so we need to pick out what a is. Well, a is just that base, which is 6, okay? And then I want u is the exponent, 3x minus 4, and then so the derivative of that is 3. So when I get ready to take the derivative, you can see that the derivative is going to be natural log of a, okay, times a to the u times du. So I just need to fill in for all those pieces. So I get natural log 6 times 6 to the 3x minus 4 times 3. And there's absolutely nothing I can simplify in there, because remember, whatever's behind the ln is locked in. You can't multiply that 6 with that 3. Whoops, hold on, sorry. We'll switch back. Okay, so the derivative is just 3 times the natural log of 6 times 6 to the 3x minus 4. So these are just kind of plug and chug formulas. All right. When I look at b and you see this power, this we talked about it in a couple of lessons ago when we were rewriting those logs. The first thing I'm going to do before I start this one is I'm going to rewrite it. Right, so g of t would be 3 times log base 2 t squared plus 7. Use those properties of logs. Bring that exponent down. All right, so now for this one, let me figure out and look in my box, you know, which formula that I'm using. And so I'm going to be taking this one, okay? So I need to get the pieces, all right? A is the base. A in this case is 2, okay? And then I want u, which is just that t squared plus 7, and then du would just be 2t. All right, so the derivative, all right, it's going to be 3 times, all right, and the derivative formula is going to be, you can see up there, 1 times the natural log of a, all right, times u times du. So if we fill all that in, it's just 3 times 1 over, right, natural log 2 times t squared plus 7 times 2t. So I'm going to get 6t over natural log 2 times t squared plus 7. Okay, these are not bad as long as you have those formulas. If you don't have the formulas or don't have them memorized, then they're extremely difficult. All right, and then let's look at the integration. Right, so we're just going backwards, and so you can see your integration formula. Integral of a to the x dx is 1 over natural log a times a to the x. You can also interchange that x with a u, and we'll do one of each. So if we look at the first one, integral of x to the 4th plus 5x dx. All right, I'm going to separate it out because I've got my regular power rule, and then I've got this new rule where I've got this other base. All right, so we know how to do integral of x to the 4th, regular power rule, add 1 to it, divide by the new power. All right, so that one is just 1/5 x to the 5th. I'm not going to put my plus c till the very end. Okay, but now when I look at this one, I'm going to use my integration formula. So I need to figure out what a is. Well, a is just the base, so a is 5. So I'm going to plug into this formula right here. So to integrate this one, I'll bring down that plus. Okay, it's 1 over the natural log of a, so that's 1 over natural log of 5, times a to the x, which is just going to be 5 to the x, plus c. Okay. All right, now let's do one that's not a plain old x, where we have to do the u substitution kind of thing like that. So when I look at this one, I see that my base is 6, so I know what a is. A is 6, but I don't have a plain old x as the exponent, so I'm going to let that be u, which is x plus 4 squared. So then du is going to be use a chain rule. So remember chain rule from Cal 1, exponent times coefficient. Same parenthesis, but drop it by 1, so it would be to the first power now. And it would be times the derivative of the inside, but the derivative of the inside is just 1. All right, so it's 2 times x plus 4 dx. All right, so let's think about this. All right, I've got the integral, right, and I've got 6 to the u. So that's coming out. All right, now I need 2 times x plus 4 dx, and I just have x plus 4 dx. So if I need to multiply with that 2, I cancel it with the 1/2. So then the 1/2 comes down, and now I've got 2 times x plus 4 dx is just du. Okay, so we're going to use the same integration formula, but everywhere I have an x, I'm going to put a u. Okay, so this integrates as 1/2, all right, times 1 over the natural log of a. All right, so in this case, a is 6. All right, so I get natural log 6 times a to the u now, so 6 to the u would be 6 to the x plus 4 squared. Plus c. So you could write 1 over 2 times natural log 6 times 6 to the x plus 4 squared plus c. All right. And I went ahead and I threw some extra examples in here just to make sure everybody was on the same page. Everybody knows when you're taking, I just did some derivative examples, but look at these. You know, think about what you're doing. Think about how the problem is presented to you. Like if I look at the first one, and I want to just find the derivative, f of x equals pi to the pi. You want to ask yourself, like, what is pi to the pi? What part's the variable? There's no variable in there. That's just, you know, that's like the same as me asking you the derivative of f of x equals 2 to the 4th. Well, that's just f of x equals 16. The derivative, that's just a constant, okay? That's just a number. If you plug in pi to the pi on your calculator, you just get a number. And so we know that the derivative of a number is just 0, okay? All right, so if I look at the next one, f of x equals x to the 4th, we know how to do that. Derivative of x to the 4th is just 4x cubed. Okay. So don't make g any different, all right? F of x equals x to the pi. Remember, pi is just a number. These two are the same. They're both x to some number power, okay? So when I take the derivative here, I'm sorry, I should put that derivative there, sorry. F of x equal would be pi times x, and then you got to drop it by 1, so pi minus 1. Okay. Those are the same problem. Okay. Now, h is where it's different. H is our new rule, the one that we just had a second ago, because the x is the exponent, okay? So remember, the derivative of a to the x is equal to a to the x times natural log of a. Right, so in this case, all right, a is going to be pi. So when I fill in that derivative rule, I get pi to the x times the natural log of pi. Okay. So pay attention to which part's your variable. Is your variable in the exponent? Is your variable the base? You know, look at it like that. And then we've got one more. So when I look at this last one, I got f of x equals x to the 2x. I don't have a rule for this, okay? Because this is a variable raised to a variable. I don't have a rule. This doesn't look like any of those first 4 that we just did. So what I can try to do is I can try logarithmic differentiation, which we looked at a couple of lessons ago. So let's do that real quick. This one is not bad at all. I'm going to replace f of x with y. All right, so let's think about our steps for logarithmic differentiation. First thing we had to do is take the natural log of both sides. So when I take the natural log of this right side, remember I can bring that down, that exponent down to the front. All right. Second step was to take the derivative implicitly. So the derivative of the natural log of y was just whatever's behind the L in the bottom, derivative of that on top. And anytime I take a derivative of a y, I follow with y prime. Now, when I take the derivative of this right side, I've got to do a product rule. So it would be 1, right, d2, derivative of the natural log of x, plus 2, d1. Alright, so let me write that a little bit cleaner. When I get ready to simplify this, these x's cancel. And so I just get 2 plus 2 natural log of x. And remember, our goal is to get y prime by itself. So what I'm going to do is multiply both sides by y now. But you don't want to multiply it by y. Alright. We want to multiply by what y is. Oops. Sorry, hold on. So that was x. We want to multiply by what y is, which is your original problem, which is x to the 2x. You could, distribute that if you wanted to, but there's really no reason to do that. Just there's your answer: 2 plus 2 natural log x times x to the 2x. Okay, make sure you practice your homework problems.